Hi, and welcome again on this channel. Last time on the last bit, the previous one, we just introduced the measurement activity. Now we are going a little bit into more details, working toward finding a good model for the activity. To do this, we need also to understand some technical terms and words that are used in metrology. Metrology, as any other activity, has its own vocabulary, and we must understand it to avoid any misunderstanding with terms that are also in the normal and current use, but they have a rather different meaning from the technical one. To do so, as I told you, there is a vocabulary. This vocabulary has been issued by the BIPM. The BIPM is the Bureau International des Poids et Mesures, the International Office of Weight and Measurements, and this is the official body that rules metrology. As you can see here on the slide, this vocabulary is freely available on the BIPM website, as you see here, and the address is there, and I will put it also in the description of this video so that you can click on it directly and download it. So let's see some of these definitions, the most important ones, the first ones. The first definition that we see is, of course, that of measurement. So the vocabulary in its article 2.1 defines it as the process of experimentally obtaining one or more quantity values that can reasonably be attributed to a quantity. So as you see here, it's not only one, it's one or more, and this should trigger something and just to trigger our attention for the future. It refers to quantity and quantity values. So let's see, first of all, what is how a quantity is defined and what is a quantity value. So let's start with the quantity. As you see here on this slide, quantity is defined as the property of a phenomenon, body or substance, where the property has a magnitude that can be expressed as a number and a reference. So what is a number? We all know what it is. What is a reference? There is a note in this article, and the article is 1.1, that states that the reference can be a measurement unit, a measuring procedure, or a reference material, or a combination of such. So why? A measurement unit, usually it's used whenever we measure any physical quantity. So we measure the length of a table. The measurement unit is the meter in this case. We will discuss this more in detail in one of the next videos. A procedure can be any measurement procedure. Think of measurements like, for instance, customer satisfaction. This is not a physical quantity, but you may have some reference to follow to measure this quantity. It can be a reference material, which is normally used in chemical measurement. So, of course, a quantity value is the value that we assign to this quantity. Well, let's see now if these two definitions are enough to try to sketch a first model of the measurement activity. Actually, they are. And we can see here on this new slide that we can sketch a model that is maybe more philosophical than technical. And as we have seen, a measurement process is something that assigns a numerical value and a reference to a quantity. Now, a quantity is a property, okay? So it's a property that manifests itself in some way, and we have a single manifestation of this quantity, single manifestation Q, and it's interesting to notice that a quantity manifests itself as an occurrence, as a fact, as an event, so something that from a philosophical point of view we may think that belongs to the empirical world. On the other hand, a number is a symbol, is an abstraction, the same a reference, a measurement unit. So they belong, from the philosophical point of view, to the world of symbols. So we may think, as it's shown here on the slide, that the measurement process is something that maps a property, a manifestation of the property of interest Q onto a symbol X that is taken from the world of symbols. A first point that we have to discuss is this mapping a univocal operation. I mean, let's see here on the slide. Is a single manifestation always mapped onto a symbol? Well, this is the first point in metrology. As we have seen in the definition, a measurement is a process to experimentally assign one or more quantity values. Why this? Because this process can't be ideal, as it's shown on the slide. So this means that due to a lack in sensitivity or resolution or accuracy or whatever, we may think that there are different property manifestations, as you see here on the slides, that are different, but that we cannot distinguish. So they can be mapped onto the same symbol, as you see here. So this is not a one-to-one mapping, but it's a multi-to-one mapping. I could have modeled it also with a single manifestation mapping on different symbols. It's more or less the same, because if I cannot distinguish, it may happen that while different manifestations go on the same symbol, then if I consider another manifestation and another symbol, they can go also on multiple symbols. So now we may ask another question, looking at this model. And you can see it. What is a measurement result? Can we state that a single number and the reference are a measurement result? Well, of course not. Why? Because for all the non-idealities that we have, we cannot know the true value of a measurement. Sometimes, think of quantum physics, we cannot even define the true value as a single value, but rather as a probability distribution. So, as a matter of fact, a measurement result can provide only a finite amount of information about the measurand. This is directly related to the fact that different manifestations of the same property are mapped onto a symbol, or that a number of symbols can be assigned to the same manifestation of the property. So, can we still use this measurement result even if it doesn't allow us to get full information about the measurement? Well, yes, it is possible, and as you can see here on the slide, we can do this if we can assess whether that amount of information is sufficient for the intended use of the measurement result. In this case, we can still use the result, and we can use it in practical application and efficiently. So now we can see one more definition, which is the definition of measurement result. It's again given by the vocabulary, Article 2.9. It says that a measurement result is a set of quantity values. So not only a single quantity value. This is meaningless. It doesn't carry any information, but a set of quantity values being attributed to a measurement together with any other available relevant information. Why do we need this? Because, as we say, a single value is not enough to represent the measurement, because for all known idealities we will never get the true values. So we need, we have a set of values that somehow are dispersed around the measurement value, and this additional information is something that allows us to state how much dispersed is this set of values. In general, you can see here on the slide, the vocabulary states that in general a measurement result can be expressed as a single measured quantity value and a measurement uncertainty. So this is the other keyword. We will see later that uncertainty is one of the pillars on which metrology is based. And we will discuss this later on in the future. But to do this, we need the model. So let's go back to our model and let's see how we can define this mapping operation that provides us a set of quantity values. So now we have the same model as before, but we can identify some processes to map this property onto a symbol. So, of course, we have the experimental processes, which is the experimental activity, the activity that we perform with instruments. This is rather obvious and trivial. But we need to find this additional relevant information. So we need also a number of descriptive processes that can identify and implement the mapping operations. And what are these descriptive processes? Well, they are, and we will see this in the future videos, they are as important as the experimental ones. And to explain them, we need that more complex model that we have already seen at the end of the previous video. And what is this model? Here it is. You see, it has a number of processes that are now shown on the model. For instance, the identification process that identifies the object and the property of the object that we want to measure. It identifies a model for this object and its property. It identifies the experimental processes, most important, their interaction, and so on. So this is what we are going to see. This is what we need to study, not only to understand what a measurement activity is, but also to find the origin of all those non-idealities that make the measurement result somehow wrong, so that not capable of catching the true value of the measurement. How can we do this? Well, this is rather long to see, so let's see it in the next video. Stay tuned on the channel, subscribe, and have a great day. Bye.